So this is my lab for this week. It's on constant velocity motion. My name is Zukar Islam and I'm in lab section M08. I'll start off by talking about my observation. I made my observation about a marker rolling across the table, and it was going at a speed that I thought was constant. And so from that, the main result should be that if the net force is 0, then we have a constant velocity. If the F net is not 0, then we have some acceleration. And if we have acceleration, then we have a change in velocity. So I'll show you guys my video right now. I'm pulling it up. As you can see right here, this is the video. There we go. This little pink round disc right here is the diameter of the cap. And I measured that by using this dark blue tool. It's called a calibration tool. And I did that because I wanted like a fixed scale to properly record the distance that the marker traveled. And as I play the video, these little blue circles and diamonds, they represent the marker's position at certain times before it hits this little crack and stops. From doing this video, I was able to get these data points I just highlighted right here in the bottom right hand screen, and I was able to get those and put them into Microsoft Excel, where I pasted them right here. And then I plot it on this graph right here, and they're represented by the blue diamonds. You can barely see them, but they're there. And with that, and you can tell from the slope of this line that it's constant velocity because it's a straight line. So after I got my data points from the video, I was able to start making my model. And so the initial conditions of my model to represent the motion of the marker are as follows. Everywhere you see ball, just pretend it says marker because I forgot to change it, but it should say marker. Here you see the mass. I put it as 1, but it's kind of irrelevant, and I'll explain that later. But the original position of the ball, I put that as 0, 0, 0 because I wanted that at the origin. And the ball velocity, I found that by getting an average velocity from the video, which I got that by doing delta x over delta t, which is your change in position over change in time. And from that, I got about 0.43 meters per second. And so I inputted that as the x component on my vector, my velocity vector, because the marker is only moving the x direction. So using this information, I was able to start writing my model, which is indicated right here. This is the actual physics part of the model that involves all the concepts. Here I set the force equal to 0 because I don't want a change in velocity, and to ensure that I have to make sure that the force is, or the easiest way to do that is to show that the force is 0. To predict the velocity of the balls, as a marker I have to do the velocity plus acceleration, which is equivalent to force divided by mass, times t. But here, like I said, I set the force equal to 0, so 0 divided by any number is still going to be 0, and it's being divided by the mass. So this is the only part where mass is even considered, but like I said, it's kind of irrelevant. And then position is found by adding your initial position to velocity times time. And so I'm about to run my program now so you guys can see the model. Here's the ball, it's indicated. This red line is the motion of the ball, and it's only short because it was a short time span and a short distance. So after this model, I was able to get more data information and put that into the same Excel file, which I indicate right here. And then I graphed it, and it's graphed on the scatter plot with this red line. And as you can see, the two lines are pretty similar. So that pretty much means that my model is pretty accurate compared to the actual motion of the marker. And both of these straight lines indicate that there was a constant velocity. So then that leads me to this what if portion of the video, what would happen if I oriented the x in a different direction. So here on my video, I oriented the x-axis going this way, so that I would have positive x values. But say I was to switch my x-axis going the opposite direction, I would just have negative x values, and my slope would be indicated by a negative velocity because I wanted to move in the same direction. And so what does all of this mean? It means that the force acting on the marker was 0, and that is because there was a constant velocity. Had there been a force present, there would be an acceleration present, and with acceleration is a change in velocity.